All right, thank you everybody for coming today. My name is Bryan, and I'm a data engineer. I have been a data engineer for 24 years. It has not always been called data engineering in those times. I've done roles from logging, data warehousing, architecture, BI reporting, everything in between. And 11 of those years were spent at Facebook. I saw things from when Facebook was just getting started early on, all the way through to the meta years. And the last 2 of those years have been at OpenAI, where I am now. The rest of them across various non-tech, small tech, and stuff industries. The most important lesson that I've learned in my career and over all those years is that standards matter. They are the thing that is durable. In one of the many standards-related posts that I've written on Slack, I recently had a loving coworker write, "I'm envisioning Bryan as the sole surviving monk of the holy text of data best practices that he updates as part of his daily ritual." And I'm not too sure if he intended this to be a compliment, but I thought it was hilarious. So I actually put it on my internal profile, and I actually wanted to kind of use it as the guiding principle of this talk as we talk about why these things are important. So data engineering is different from data science because data science's output is ephemeral. They do a study, they produce a result, they make a decision, they may rerun it a few times, but of course everybody always assumes that the world's changing and that was what it was back then and maybe we should rerun this analysis. It's understood that that analysis was of that certain point of time. And data engineering is different from software engineering because software is fluid. Bugs can be fixed, clients can be updated, features can be launched and deprecated. But data engineering, unlike our partners, produce numerous heavy load-bearing artifacts. So when we produce a table, that represents the view of the certain point of time that we had, it's there forever. It finds a way to become the source of something new. It purports to be current, even though maybe the logic has kind of decayed. And when we produce a bug, even though it's in an ETL script that needs to be patched, it leads us to probably the single most terrifying word to a data engineer: backfill. So each new fix, each new addition, we have to backfill history. There's downstreams of that history, and that's why the stakes are higher for us. This is the things that we can do about that. One of the tools that I've learned or approaches is pithy one-liners. These are ways to consolidate knowledge and the original distillation of intelligence, if you will, things that people are going to remember and say and internalize. The first one that I like is the code base should read as if one person wrote it. I think I picked this one up from an Instagram engineering manager years ago, and I really liked it, and I started using it because it captured what I was thinking and wanting to communicate. When you inevitably need support, or when you modify code, or you have to read your teammates' code, it shouldn't look like you're integrating with some acquired company because things have drifted so far away. When we keep things standard, we keep them easy to maintain, easy to expand. Messing this up is what breeds duplication and incompatibility. Another one is more important than which. This is one that I've coined after saying this for a very long time. If we use the same tools and the same workflows, improvements can be shared by everyone. So instead of having to hunt for adoption, this is just the way that it's done. And so if you can improve the efficiency of the way we all work, then everybody can benefit from those, as opposed to people starting to customize things for their own personal style, which kind of leads to that first problem. It only gets harder. This one, there was a viral YouTube video from a Duke women's basketball coach a few years ago that really stuck with me, talking to her team about, you're waiting for it to get easier and it never will. It only gets harder and you get better at dealing with the hard times. And I think about the early parts of my career and the types of data problems that I used to handle. And that really kind of sticks with me. The tools and the knowledge and the techniques that we have today would make super fast work of that stuff from 10 or 15 years ago. Today it's table stakes and it's the way that we do. And in the future, it's going to be table stakes as well. And we have to keep adjusting to those things. Migrations and big tech debt cleanups can be daunting, but when you're working at an established company, don't you kind of wish the data engineers before you had invested the time to get those things fixed? So, as someone who worked at early Facebook, I probably owe some personal apologies to some of the metadata engineers in here. So, sorry about that. And just think about like future generations and people that will be building off of your work. And the last one is that people will take the path of least resistance. I guess electricity taught us this one. People will optimize for the outcome and choose whatever way gets them there the fastest. So if you've ever wondered why someone would duplicate a whole system just because one feature didn't exist in another one, this is why. So I've been preaching these for years, and you're probably thinking like, okay, well, are these still relevant in the age of AI when we can kind of make our own changes for these things? And this brings me to one of my favorite charts. This has been my personal experience over these last crazy few years. Just 4 years ago, we were hand typing like Neanderthals, and we thought like we're great, engineers, and this is the way it works. And then along comes ChatGPT, and it can answer coding questions, and it's a much better search experience. And then tab to complete quickly follows in the IDE, and it felt like magic. And then we got to the point of being able to write whole code blocks and things were generating all at once. And we thought this was bliss. And then right around the end of last year or so, we hit what I've called Codex liftoff. And all of a sudden, everything changed. I personally haven't written a line of code in probably 9 months. And everything now is in this kind of peak vibe era, which is where we are right now. You just kind of make a wish to the Codex Genie and it grants it. You don't even have to have full context of the pipelines that you're building. You don't even really have to know the systems that we're adding logging to that are in languages that we don't know or have never seen before, but we trust it. And for the most part, it does a good job. And it was around this time that OpenAI published an article titled Harness Engineering. And I had an epiphany. Instead of trying to convince everyone, kind of like I'm doing now, about how important these standards are, and then convince the people that come next and the people that come next and so off, I thought maybe since people take the path of least resistance, maybe what we can do is bake the output of Codex directly into the system. And so if I can make it follow the standards that we have established to use the tools that we've chosen collectively, then DEs won't have a reason to deviate. It'll just be the way that it runs. So this article, if you have chance or time to look through here, and I think we'll share the slides afterwards, introduces this concept or ideas of a knowledge store, of execution plans, of ways that agents can use this and how they can leverage it. And so this is our knowledge store for data engineering at OpenAI. This is what it looks like. We have a skill with instructions called Sage. Sage is our name for our internal low-level ETL system that runs on a WAP concept, which is write, audit, profile, and publish. So a low-level set of APIs and functions that we build all of our ETL and pipelines on. And then the agents file that lives under the directory where all of this code lives directs it back to load the skill. So the skill loads the agents file loads the skill. This way, in case you've forgotten what the skill is or didn't know because you're not a data engineer or you're new, you'll be protected and you'll be covered. Now, originally, we loaded all of this context that I've talked about, all of these standards and guidelines and principles into the agents, and predictably, it failed. And then as we started iterating more and this knowledge store thing came around, we started treating these things as books in a library. So now under our docs folder, we treat each of these different concepts as a document that can contain all of the knowledge that we hold as the way that we should be doing data engineering and the way that we should be building things. And the skill and the agents files work together to help route into that and find what should we pull in when the model needs that information and not overloaded with a bunch of context that it doesn't necessarily need. One little trick, if you have tried this before, that I found helps a lot, is to tell the model that when it comes in and reads one of these library books, to make a note, to output it into the screen that you'll see kind of in its chain of thought there. And if it defers any, to say, I think I'm going to need that later, give a reason why it needs that. I found that this made it a lot more accurate in terms of coming back and remembering in the beginning or at the end that it needed something in the beginning, that information is still there. That kind of helped it rein it in a little bit. And our agents file is, like I mentioned, largely routing to other skills or telling it like how to proceed, how to find the information it needs, not necessarily containing tons of context and directions and stuff. So it'll also mention it to other types of skills, like how do you run a backfill so that it can manage it so that we don't have to do it anymore. But also like how to run like local tests and other types of things that we do. Here's an example of one of these books. So for example, a data modeling book, something that I hold very near and dear to my heart. And it talks about some of our principles, especially naming conventions, which is another thing that I'm famously known for being a very big stickler for. Naming conventions help convey what's in the table and what we should be looking at, what we should expect from the table or do with the table. So this is an example of where it talks about the different types of tables, what we call them, how they react to each other, how to name them according to our stuff. And then it goes through like how they should relate, the types of stuff that we should include. So this is something where if the task that we're doing does not actually need to be doing architecture or modeling, it doesn't need to load all of this context. And if it does, it can come here and it can check it and follow it up later. So now when people are vibe coding a pipeline, the agent can read these things, and we can also start putting these into our code review agents. So as something comes in and starts reviewing code and saying like, okay, we've got a second set of eyes that can come into this and say, these are the standards, these are the things that we should be looking at. And so if I come back to my shift and workflows thing, it had kind of occurred to me that in the traditional sense, really the difference as we move across is the amount of instruction that we're giving the models or that we're feeding things in. So we used to give 100% of instruction by doing this traditional hand typing, and then maybe 10% instruction in the case of Vibe, where you have to fill out your prompt and follow up and follow up. And so what about 1% instruction? And that's kind of where we are here as we've started to look at how can we develop more and more autonomous DE agents to do things. And so that brings us to one of our first DE agents that I want to share, which is named Tidy. Tidy was inspired by another post that we've done. It's got ImageGen did a really amazing job here in terms of creating this image. Does that show up on the screen? It's a little bled on mine, but maybe not. It's this robot or agent that comes and does all of this little quick cleanup work. So these are going to be things that are never worth the time of a data engineer to do, but they compound into those small bugs over time and create a lot of cruft in the long term. So, and you know, since Codex loves looking for context in nearby files, it picking up some of these like old standards and things, it would start to propagate further, even in new development. And so it's just kind of a little annoyance that we've got in there. So it was inspired by another post that we had a few months ago for a project called Symphony. Symphony is an open source, open spec system that leverages Linear, which is a task management tool. It spawns independent Codex workers that then run these threads and execute on work. The authors encourage us to fork it and customize it for our own needs. So that's what I've done. And that came out into this capacity. So the way that Tidy works at its core is the core piece of unit is what we call an evergreen task. So an evergreen task is like a really high level, what do we want to have accomplished? And we want Tidy to go out and find all of the work to do. Kind of like if you tell your kids to go rake the leaves, you don't point them to every leaf pile. They'll go find where the leaves are and they'll, let you know when you're done. And then you can tell them to do it over again if they didn't do a good job, which is pretty much my relationship with Tidy. So in this case, the first example, as I kind of mentioned, we use this ETL framework called Sage. And over time, we've done a lot of development. And so the way we do things now is a little different than the way we did it before. And so there's a lot of these like old standards and backwards compatibility. So this is the full prompt that I've given Tidy in this case. And I said, go through this jobs directory, look at all the different code from all of the different teams, and compare it to that knowledge store that I mentioned. It has all of the conventions, all of the standards, all of the things that we want to do, and then look for things that you can modernize. And so it goes through, it spawns its own tasks. Each day we have it little metered so we don't get like totally overrun, but it goes through and starts creating this work and starts cleaning up these things. And some other examples of types of tasks that we have it run on are like standardizing on the types of sensors we use, or deprecating old tables, or getting rid of useless like DQ checks. Not that all DQ checks are useless, but some of them are a little redundant, and so on and so forth. So these are the kinds of things, like I mentioned, that are important to keep on top of, that are probably going to create some problems in the future if we don't take care of them. But who's got time for that? This is an example of linear. So this is kind of the Kanban board view of linear, where we can see the evergreen tasks that we have. We can see which ones are in progress, which ones are waiting for human review, which ones it's completed. And this gives us kind of a good interface. Inside each of these tasks is a workboard, so I can also see what is Tidy working on, what has it done so far, is it stuck? I can communicate with Tidy through this task interface if I need to. It mostly just gives me a little bit of visibility as a human in there. And so the general loop that it runs through is Tidy will generate a task. It'll write a PR and run all the local tests, including local test for like test or staging data. And then it will submit the PR to a reviewer. It'll do its best looking at nearby code owners or other people who have touched recent blame on a particular file. And then it'll send them a Slack message and say, hey, I'm Tidy and I've got a PR here for your review. If the reviewer has any feedback, or if there are any build errors or anything like that, Tidy will keep looping on that until the build is green, there's no more outstanding feedback requests, and the reviewer has stamped it and said, go for it. Once it has PR approval, Tidy goes and merges it and then moves on to the next one. It does a couple dozen or so in parallel as it goes through here. So the only human in this loop is the reviewer, of the person who has context on reviewing that pipeline. We don't have to have a data engineer or anybody going and like doing all of this like menial work, but it's important for us to do. Here's a screenshot of like a little dashboard that I get also just to kind of keep an eye on like the high level type stuff for Tidy. I took this screenshot yesterday, running with 5.6 Sol. It's generated over 100 PRs in the last 2 weeks or so. These are 100 cleanup PRs that have cleaned up the dust, little things that could break later, little things that could be SEVs, little things that could spread elsewhere into the system if we don't do this, that nobody else was going to do. So this has already been a pretty big help for us. So who's writing and maintaining your holy data texts? Because I'm envisioning you as the sole surviving. Okay, I'm not going to read all that, but I hope that the talk has inspired you. The importance of these things, now is the time to do it, because it only gets harder from here. Getting this stuff set up will make your lives way easier, not just for you, but for the generations that come later, for the people who have to inherit this code and these systems. And as you also move on in your careers, you will hope that the people before you put this much care into the systems that you have to work with. Thank you.